Hi everyone, welcome to my channel. Please like and subscribe. In this video, we'll be learning on how to read structural drawings for column footing. In order to interpret effective structural drawings for column footing, you need to have two types of structural drawings, which are foundation layout plan. This one, foundation layout plan. This is a foundation layout plan, and structural drawings for reinforcement details for column footing. Now this is reinforcement details for column footing. Now let's start with foundation layout plan. This is a foundation layout plan. From this foundation layout plan, used to identify the location of column footing and its types. As you see from these drawings, this is where column footing are placed. This column footing are placed at the center of grid lines. At the center of grid line. Now, this is the column footing of type 1. This is column footing of type 1. All of these from these structural drawings, all of these are column footing of type 1. Also, this foundational layout plan used to identify the location of column. As you see inside of this column footing, there is column. Now, this mark used to represent column. Columns. These are columns. These are column. This column are also placed at the center of grid lines. At the center of grid lines. These grid lines are passes horizontally and vertically, and column passes at the center of these grid lines. Also from this foundation layout plan, you may see this mark. This mark used to represent the footing level. Now, as you see, this is 1.8 meters. This 1.8 meter means that the footing should be placed. At 1 meter below the ground level. As you see from this one, this is a footing, so should be placed at 1.8 meter. 1.8 meter from the ground level to this level. This is the footing. So the footing should be placed at this height. Also from this foundation layout plan, you may, as you see, use to identify the types of foundation. From this foundation layout plan, it shows that this one is a paddy footing. This paddy footing and this one is a paddy footing. This paddy footing used to connect individual columns. And also, as you see, this column are supported by two columns. So this is a strap foundation. Strap foundation used to support two columns. Now this is strap foundation, and this one is a paddy footing. These are strap foundation used to support or connect two columns. So this is the strap foundation. Second, let's check the reinforcement details for column footing. Now this column footing, it is of two categories. Now this is footing section. Now this is the footing section. This one, footing section, which is section 1.1, and this one is a footing plan. Now let's start with footing plan. This footing plan is column footing of type 1, which its dimension is 1.5 meter by 1.5 meter by 350 millimeter. So this means that 1.5 meter is the length of this footing, and 1.5 meter is the width of this footing. This is the width of this footing. Also, this 350 millimeter is the thickness of this footing. As you see, this arrows used to present section 1.1. Now, this is section 1.1 is this one. So from this section 1.1, you can see this one. This is the thickness of the column footing. Now, this number 28 used to represent the total numbers of column footing required for this design. As you see, all of these are column footing. So this 28 represents the total number of column footing found in this structural drawing. found in these circular drawings. Also from this foundation layout plan, as you see, this one is a column, the column size, which dimension is represented by this section, represented by this section AA, which is dimension is 230 millimeter by 230 millimeter. So this is the column size, which is 230 millimeter by 230 millimeter. Also from this foundation plan, as you see, used to show how the reinforcements are arranged. So the reinforcement for column footing are arranged into perpendicular direction, are placed horizontally. So these are reinforcement placed horizontally, which are represented by bottom one, and this one are reinforcement placed vertically, which are represented by bottom two. Now let's check the reinforcement detail for bottom one, which are horizontal reinforcements. Now these are horizontal reinforcements. For bottom one, the reinforcements there should be 9 bars with diameter of 16 millimeter at bar mark number 1 with a spacing of 200 millimeter. Now this is a number of tail-ups required for bottom one, which are placed horizontally with a diameter of 16 millimeter. This 16 is the diameter of this main reinforcement, and 200 millimeter is the spacing of this main reinforcement center to center. This mark, this 01 is a bar mark. Also the reinforcement detail for bottom 2, which used to represent the reinforcement placed vertically in this way. Its reinforcement shows that there should be 9 bars with diameter of 16 millimeter at bar mark number 2 with a spacing of 200 millimeter, 200 millimeter, 200 millimeter. So this one is the number of bars, and this one, and this 16 is a diameter of steel bars, or diameter of main reinforcement, and 02 used to represent the bar mark, and 200 millimeters, this one 200 millimeter spacing. This is a spacing of main reinforcement, spacing of steel bars. As you see from this foundation layout plan, it have a length of 1.5 meter, and this is the center line of this column. So from the center line of the column to the edge of this footing, it shows that there should be a distance of 750 millimeter from the center line of this column to the footing edge. There should be a distance of 750 millimeter. Also, let's check the footing section, which is used to explain section 1.1 of footing plan. Now, this section 1.1 it shows that this footing is a footing of length, is a footing of this length of 1.5 meter, and from the center of this column, this is a column, from the center of this column to the edge of this footing, there should be a distance of 750 millimeter, and the reinforcement should be placed vertically and horizontally for bottom 1 and bottom 2. As you see, this is the thickness of this footing. The thickness of this footing, which is 50 millimeter. From this main bars to the soil. This is 50 millimeter. Is the thickness of blending concrete. So the blending concrete, before placing the main reinforcement, you're supposed to place the blending concrete of this thickness, which is 50 millimeter. Also, as you see, this is from the soil up to the ground levels. This is represent the height of the foundation. So the foundation should be placed at the height of 1.8 meter, which is 100 millimeter. This height depends on the site condition. Also from this section, as you see, this is a column, and this column is represented by these arrows, which are AA. These arrows used to explain section AA. Section AA, which its dimension is 230 millimeter, is to section AA, which is 230 millimeter by 230 millimeter, which is detailed shows that this column there should be 6 bars. There should be 6 bars with a diameter 16 millimeter at bar mark number 3. And from this ground level to the footings, there should be stair-ups of there should be 15 stair-ups with a diameter of 8 at bar mark number 3 with a spacing of 150 millimeter. Now this is 15 is the number of stair-ups. Number of stair-ups, number of stair-ups, and this 8 uses diameter of stair-ups, diameter of stair-ups, and this one, this is a bar mark. Bar mark used to represent, used to show where the steel bar starts and end from. And this one, 150 millimeter, used to represent spacing of stair-ups, spacing of stair-ups, from center to center. Also at the top of this section, at the top of this footing section, as you see, this is a column starter bar. Column starter bar used to connect footing and column. Also, this column starter bar used to provide the continuity of reinforcement. Here at this section, the reinforcement it provides the continuity of reinforcement. Also, this column starter bar used to maintain the required slab length. As you see, this is a lap length of 900 millimeter. This is a lap length of 900 millimeter. This lap length is a length of which the two main reinforcements overlap. Also, as you see, this is ground beam. The ground beam, which is represented by this mark of 0.45. Now, this mark used to present the level mark of this ground beam. This ground beam which have a dimension of 230 millimeter, dimension 230 millimeter by 300 millimeter. Now, this is a thickness. This is a thickness of oversight concrete, which is a thickness of ground level, which is thickness is 100 millimeter. Thickness of oversight concrete. Now, this is a way on how structural drawings for column footing is interpreted. Thank you for watching this video. Please like and subscribe so as to be notified for the next video. See you.